Alright guys, today we're going to do the next kind of factoring, which is factoring of the form where you actually have a leading coefficient that's not 1. So we call this ax squared plus bx plus c factoring. Now it's still trinomial factoring, meaning we know that our answer is going to be in the form of 2 parentheses, and these two are going to be binomials. And it's really honestly the same concept, because like we're going to use that whole FOIL trope in that, you know, we want these outer and inner terms to be able to add so that they're so that the factors also multiply to equal this last term. But today we have to also worry about this first term, which has not been a thing thus far. So again, I'm going to appeal to your sense of reason. The fact that we all know our multiplication tables and we know how to add and subtract. Okay, so just follow with me. When you get done with this video, you do have an assignment. It's like a 5-question little, I think it's like, it says lesson quiz or something. It's just a practice. I want you to try it out, and then we'll talk about it tomorrow. Okay, so let's start with a nice first one that all we're doing is adding. So here we have 5x squared plus 19x plus 12. Okay, so we still have a trinomial, you have a squared term, a linear term, and a constant. And again, we know that we're going to have 2 sets of parentheses, and they're both going to be binomials. Now, now I happen to have a 5 in the front. Now, obviously we multiplied before, right? We know that we're going to have to do something with that 5. This particular one is kind of nice because 5 is a prime number. It only has 2 factors, right? So I know that one of these has to be a 5x and one of these has to be a 1x. That's the only way I can multiply it together and get 5x squared. So that's kind of nice. We do like prime numbers. Prime numbers are great. However, we have 12. 12 has a different set of factors, right? We have 1 and 12. We have 2 and 6. And of course we have 3 and 4. Those are the different sets of the factors of 12. Now what we want to happen is we still want it, so whenever I multiply these outside terms and these inside terms, we want their, obviously in this case, sum, because everything is positive in this problem, to equal 19, right? So that's exactly the same as the last kind of factoring we've done, but now we have to worry about, hey, I'm multiplying this times 5. It's not a 1 any longer. So I'm not just looking at only these numbers to try to get a 19, because obviously none of those do give me a 19. I know I'm going to have to, you know, to play with those a little bit. Guess and check is fine. Some of you guys will be able to do this quickly in your head. Some of you guys is going to catch on. Okay, so I'm going to do this first one wrong on purpose, so please don't write this down if you're writing in pencil. I'm going to totally erase it. So say I thought it was 6 and 2, okay? If I put a 6 here and a 2 here, look what you get. This becomes a 2x, and this becomes a 30x. 30 plus 2 is definitely not 19, so I know that that definitely can't be the right answer. Oops. Now be careful, that could be the right numbers, but I just had them switched. What if I put the 6 here and the 2 here? Well, that you can see that's still not right, because that gives you a 6x this time and a 10x, and that's a whole lot closer to 19, but obviously still not equal to 19. So you're just trying to figure out what pair are going to fit in to your binomial so that it indeed does work. There's really not a trick or method. It's honestly just so you understand your multiplication tables here. So the correct answer is 3 and 4. Those are the 2 numbers that are going to fit in there. And specifically, I would need the 3 to be here and the 4 to be here, because 5x times 3x is 15x, and 4 times x is 4x, and obviously whenever I add 4x plus 15x, that gives me my middle term of 19x. Again, I know I'm adding everything here, so that's pretty easy. So now my plus sign's in, and that's my solution. My solution is 5x plus 4 times x plus 3. Okay. Remember we did talk about how multiplication is commutative, so if your x plus 3 was in the first set of parentheses and your 5x plus 4 was in the second set of parentheses, then that's great. That's also correct. So it's the same thing. We just have to worry about there's a number in front. So multiplication and addition and subtraction. Let's do another one. The next few examples I'm going to do, of course, are going to have to do with what happens whenever we start throwing minus signs in there, right? Because sometimes we might have to subtract instead of add. And again, don't overthink this. It's literally just adding and subtracting, and obviously a little multiplication coming in there. So here's the next problem. 3n to the second minus 8n plus 4. Okay, so again, I know I'm going to have two sets of parentheses. And just like the last time, my 3 right here is a prime number, which is wonderful. We like that. So that means I know this is going to be a 3n and this is going to be a 1n, because the only way to multiply and get 3 is, of course, 3 times 1. Okay, so it's kind of the same thing with the 12 a minute ago. I know I have two different, like I can multiply and get 4 with 1 times 4 or 2 times 2. And I see here that this is a minus sign and this is a plus sign. We kind of talked about that. If you were in class yesterday, we talked about that a little bit. I know that whenever I go to multiply this times this to get 4, it's going to have to be a positive 4, right? But whenever I go to add or subtract this and this, it's going to have to be a negative 8. So obviously I'm going to have some minus signs in there somewhere. So I always think of it in the fact, and Ms. Lychuk also kind of mentioned this yesterday too, like, I know these are both going to have to be negative numbers, right? A negative times a negative, let me change my highlighter here, because I said like a negative times a negative is a positive, right? That's the only way you're going to be able to get a positive 4, unless those both happen to be plus signs. And they can't both be plus signs because I need a negative 8 in, right? So, I mean, that's really your only option. You know that both of those signs are going to have to be minus signs. Okay, so let's look and see what numbers we're going to have to fit in here. Yeah, it looks like, well, let's just try it out. Okay, if you ever get stuck, and I do this sometimes too, and I'm not quite awake yet this morning. If we put a 2 and 2 in, let's see what we get. We get 3n times negative 2, so that's a negative 6n. Excuse me. And then we get a negative 2n in here, and look at that. That works right off the bat. If I add negative 2 minus 6, right? Negative 2 plus negative 6 is definitely a negative 8. And negative 2 times negative 2 gives me that positive 4 that I need. So that means my solution is 3n minus 2 times n minus 2. Okay, so just practice the signs. That's what you're going to be doing in a minute. Just practice those signs. That's where I always see students making mistakes, is where the signs are. Again, it's just adding and subtracting. Don't overthink it. Let's do another one. 2n squared plus 3n minus 9. Here we go. So we know we're going to have those two parentheses. 2 is a prime number. 2n, 1n, right? I know for 9 I could use 1 times 9 and 3 times 3. Now this time I do see that this is a negative 9. Alright, so that means that the two signs that are going to go in my parentheses, they're going to have to be different. Because a positive times a negative is a negative. Now, I'm not going to go ahead and put them in because I don't know where they go yet. I do have that 2 to worry about, so I do have to strategically place them. Excuse me. So the correct answer on this one, I would use the 3 and the 3. Okay, so let's look what that gives me, the reason why I know that. 2n times 3 is 6n. 3 times n, of course, is 3n. Now think about what we want to be negative and what we want to be positive. I want, whenever I add, my answer to be a positive 3. So logically, this would have to be a negative, right? Negative 3n plus 6n is going to give you a positive 3n. So that means that this sign here, that 3 needs to be negative, and this 3 would need to be positive. Because that way, that would give me a negative 3 and a positive 6, so they added correctly to give me a positive 3, and a negative 3 times a positive 3 gives me a negative 9. Just like I said before many times over, these are always easy to check. If you're you know, if you're not sure if you have your pluses and minuses in the right spot, or you feel like you have the right numbers, but you're not sure if they're in the right spot, take what you think is the answer and multiply it all the way back out. Just like start from scratch if you feel like you need to, right? So like down in the corner in the bottom, okay, is 2n minus 3 times n plus 3, is that the right answer? And just work that out, because we did that before and you guys were really good at it, right? That's going to give me a 2n to the second, a plus 6n, a minus 3n, and a minus 9, right? I just did that distributive property thing, right? And I can see that 6 minus 3 is definitely 3, so my answer is 2n squared plus 3n minus 9. That was my problem. I know I have the correct solution. Okay, so these are super easy to check. No excuse at all in not being able to check these. It's just you're undoing that multiplication. All right, let's do one last one. And then I'm going to let you guys, I know we have a short period today because it's Wildcat Wednesday. Here we go. 3p to the second power minus 2p minus 5. I just wanted to do one of each with all the combinations of the positives and negatives there. Excuse me. Now this one actually, in my opinion, is probably one of the easier ones because everything is prime in this problem. Here we go. So I have a 3p and a 1p, right? And there's only one way to get a 5. It's 1 times 5, right? I just need to figure out, where do I put the 1, where do I put the 5? Again, obviously I'm going to have some negatives in here somewhere. I would want to put the 5 here and the 1 here, because, excuse me, 3p times 1, of course, is 3p. 5 times p is 5p. And I want a negative 2. So that means I need this 5 to be a negative 5. Because negative 5 plus 3 is obviously negative 2. So this would need to be a negative number, and this would need to be a positive number. So the factored form of this one is 3p minus 5 times p plus 1. Okay, so now that you've hopefully taken the time to listen and take good notes and all that fun stuff, I want you to go, again, it's called, I think it's called I can't remember, it's lesson 7.5 or 7.6 or something, and I know it says quiz, but we know it's not a quiz. I just want you to practice. There's like 5 questions, and I want to see where we're at with it. Okay, I want you to genuinely try it for me, and I will see you guys tomorrow. Have a good Wednesday.